Good morning, students. Now, HS second year mathematics, and we are doing application of derivative chapter 6. We have already started exercise 6.2. Now, this is increasing decreasing function. Already we have completed question number 3. Now, we will start from question number 4. In question number 4 is said that find the intervals in which the function f given by fx equal to 2x square minus thrice x is strictly increasing, and second portion it is given strictly decreasing. So we have to find that within that interval it is strictly increasing and strictly decreasing. So exercise 6.2 and question number 4. Here fx is given what? 2x square minus 5x. So this is our question. Now in doing this we have some technique. Technique is what? You have to differentiate it first. So if we differentiate it, then f dash x becomes x2 is constant will come out, x square differentiation is twice x, so twice x into 2 is 4x. Constant is 3, differentiation of x is 1. Then according to the procedure, you have to take if f dash x equal to 0. Then what you get? 4x minus 3 is 0. This implies x is 3 by 4. How? Because f dash x is this. F dash x 0 means this term is 0. And then 4x you have is equal to 3. So x will be what? 3 by 4. Now if we consider the number line 0, 1, 2, 3, 4. So it is 3 by 4. This side is what? 0, minus 1, minus 2, so it is up to minus infinity, and this side is what? Plus infinity. So total number line is divided into two parts, for minus infinity to 3 by 4 one part, and 3 by 4 to plus infinity, and of course we will take the open interval. So you see, for minus infinity to 3 by 4, if we consider this interval, then you see any point you take, suppose 0 is lies between this one. If we put 0 here, then f dash x is what? Minus 3. So f dash x is negative, and for 3 by 4 to plus infinity, f dash x will be what? Now see here, any point you take, 3 by 4, it is after that 1, 2, 3, 4 up to infinity. 1 if you put, 4 1s are 4, minus 3, 4 minus 3 is 1, positive term, so it is greater than 0. So what you can say, for this one, f dash x is positive. So at that interval, fx is what? Strictly increasing. And as f dash x getting negative in this interval, so you will say at that interval fx is strictly decreasing. So we will write, therefore at minus infinity to 3 by 4, fx is strictly decreasing, and for 3 by 4 to infinity, fx is strictly increasing. So increasing y as it is positive, decreasing y as it is negative. So this is the technique of doing this sum. So this is our question number 4. Both A and B. This is actually A, and this is what? B. So we have done both the part. Now we will do question number 5. Question number 5 is like that: find the interval in which the function f given by this is strictly increasing, strictly decreasing. So we can do this sum like earlier one. So here fx is what? 2x cubed minus 3x square minus 36x plus 7. So this is our fx. So this fx, now f dash x will be what? Differentiation of these things with respect to x. 2 is constant, it will come out, x cube's differentiation is 3x square. So 2 into 3x square is 6x square minus 3 will be here. It will constant, it will remain same. X square, its differentiation is twice x. So 3 into 2x is 6x only minus 36 is constant, differentiation of x is 1, so only 36 will be what? As differentiation of x is only 1. Differentiation of 7 is 0. So this is our differentiation with respect to x. As earlier procedure, if f dash x is equal to 0, if we take this is 0, then of course we will get what? We will get this one like that. It is implies this one will be 0. Take 6 common, x square minus x minus 6 is equal to 0. Then you see that our formula for factorization, or process of doing middle term factorization, is what? That x square, 6 can be written as 3 2 are 6, and 3 minus 3 plus 2 can give minus x equal to 0. Then taking x common, x minus 3 plus 2 x minus 3 implies x plus 2 x minus 3 equal to 0. So we get what will do? X is minus 2 from this one. Because x plus 2 is equal to 0 gives x minus 2. X minus 3 equal to 0 gives x as 3. So we will get two values of x, and this is like that. Now it is our time to draw the number line. If we draw the number line, then you see that little we have to clean. Right. So if we draw the number line, you will get what? 0, suppose it is 1, minus 1, then minus 2. Minus 2 is here. 1, 2, 3. This is our 3. So we get minus infinity to minus 2. Then minus 2 to 3, second interval. And third interval is what? 3 to plus infinity. So we get 3 intervals. Minus infinity to minus 2, minus 2 to plus 3, plus 3 to infinity. So now we will write for this interval minus 2. F dash x already we have calculated. It was what? 6 into x square minus x minus 6. This, if we put any value, minus in between minus 2, infinity to minus 2, suppose minus 3 if we put, minus 3 square is what? 9. Minus of minus 3, that is plus 3, minus 6. So what we get? 12 minus 6 is 6. Is it a positive term? Why positive? If we put any value in between minus infinity to minus 2, suppose minus 3, if we put here, minus 3 square plus 9, minus of minus 3 is plus 3, so 9 plus 3 is 12, 12 minus 6, it is 6, so it is greater than 0. And if we take minus 2 to 3, this interval, then f dash x becomes what? If we take any value, in between minus 2 to 3, you can take minus 1, 0, 1, 2, any value you take. Suppose for our convenience, if we take 0, if we put here 0, minus 6 will come, and it is what? Less than 0. So what we get? So for that interval, our f dash x is negative. Now our last interval for 3 to infinity. In this interval, f dash x becomes what? Any value you take. Suppose in between 3 and infinity 4, suppose you have taken. 4 squared is 16. 16 minus 4 is what? 12. 12 minus 6 is 6. So it is greater than 0. So what we get? At this and that interval, f dash x is what? Positive. So we can say it is what? Strictly increasing in this interval, and at that interval it is strictly decreasing. So you will write, therefore, for minus infinity to minus 2 union 3 to infinity, I have written this two combination, f dash fx will be what? Strictly increasing. And for minus 2 to 3, fx is strictly decreasing. Why 2 to interval we have taken? Because at both the cases, this and that interval f dash x is positive, so it is strictly increasing. And for the interval minus 2 to 3, we found it is what? Negative, so it is strictly decreasing. So with that we end our question number 5. Now question number 6. Question number 6 is like that. So many sums are given. Find the interval in which the following functions are strictly increasing or decreasing. So I will show one sum, and remaining B, C, D, E I want to give as homework. It is procedure is same. So 6a I will show. Here fx is given. Like fx name not given, so we will write fx is x square plus twice x minus 5. So now as we have to find the interval, what to do? We will write f dash x. F dash x will be what? If we differentiate, it is twice x. If we differentiate twice x, it is 2 only. F dash x, that is differentiation of fx with respect to x. X square differentiation twice x. 2 to constant, differentiation of x is 1 and 5, 0. If f dash x is 0, then what we will get? Twice x plus 2, this value will be 0. This gives what? Twice x is minus 2, so x is what? Minus 1. So we get for f dash x equal to 0, x is what? Minus 1. So we can get in the number line, it is what? If you take suppose 0, then this one is minus 1, and this is minus infinity to this, and this side infinity. So we get two intervals, minus infinity to minus 1, and another is minus 1 to plus infinity. So for minus infinity to minus 1, and another interval we get minus 1 to plus infinity. So if we consider minus infinity to plus 1, that is any value, if we take from this, suppose minus 2 if we put, then f dash x, this value for minus 2, suppose I have chosen minus 2 from this interval, minus 2 into 2 is minus 4, plus 2 is what? Negative. So this is less than 0. And for this interval, minus infinity to minus 1 to plus infinity, in this interval we can take one value, it is suppose 0. If we put 0 here, then it is what? F dash x. This term 0 into 2 is 0. It is plus 2, so it is positive. So what we can say? At that interval, fx is strictly decreasing, and for this interval, fx is strictly increasing. So we will write, therefore, at minus infinity to minus 1. Remember, at this one means what? At for x belongs to this interval, fx is what? Fx is strictly decreasing, and at minus 1 to infinity, fx is strictly increasing. So this is our sum. So we get 2 to interval at which we get our term, that is value of this one, as strictly increasing and strictly decreasing. So I want B, C, D and as well as E. You will do at home and it is homework for you. Same procedure. So you can do and you can submit so that I can check this one. Or hard copy I want to submit, I want to check, and I think it is possible only when college is open. Well, now we will do question number 7. In question number 7, it is given like that. Show that y is equal to log 1 plus x minus twice x by 2 plus x, where x greater than minus 1 is an increasing function of x throughout its domain. So this is our question number 7. What they have given? Y, that is, y is actually what, fx. So y is equal to log 1 plus x minus twice x by 2 plus x. And one thing given, it is x is what? Greater than minus 1. It is obvious. If x is less than minus 1, you cannot do. Because log invalid it will be. Well, now we have to differentiate. dy dx we have to calculate. If we differentiate y with respect to x, logarithm of these ones, its differentiation will be 1 by 1 plus x. This is procedure, this is rule. Differentiation of log of things is what? 1 by that thing. And again you have to differentiate 1 plus x. 1 plus x, if you differentiate, it will give 1 only. Differentiation of 1 is 0, x is 1 only. Now if we differentiate this one, then u by v form v square, then b you keep differentiation of twice x, it is 2 only, minus twice x you keep, differentiation of twice 2 plus x is 1. Now if we take the LCM, then it will be what? 1 into this. So you will write 1 into 2 plus x square, you break it, a plus b whole thing square, 4x plus x square. Now if we break these things, minus 4, 1 plus x into this. So we can write this into that and this into that. So you see that 4 plus twice x. So I think twice x, this 2 will cancel. And only 4 will left. 4 into 1 plus x, that is 4 minus 4x. 4, these two things cancel. So we left with what? X square divided by, it is simply simple calculation, and if you have problem you do in slow way. So in this in your own way you can do. Now there is what? Domain. So this f dash x, that is dy dx, is this one. Our domain is what? X greater than minus 1. For x greater than minus 1, that is minus 1 to plus infinity. This is the greater than minus 1. For that dy dx, that value will be what? You see that if we put here any value greater than minus 1, greater than minus 1, it is what? 0, 1, 2, 3, 4, 5, 6. For our convenient, suppose if we put 0, 0 is also in between this one. This is 0, this is 1, this is, so this will give what? A term greater than 0. So as we take greater than this one, so it will be possible if it is greater than equal to. So what you can say it is 0, 0 it will be dy dx for x equal to 0. If we take suppose 2 square, it is a positive, here it is positive, that also positive. So always we will get this one is what? Greater than 0. And as this one, that for 0 it is 0, so we cannot consider x equal to 0. So we can write as it is positive, therefore y is increasing function for x greater than 1. So this is your answer. So this you have to remember, that what you have to take for x equal to greater than, your answer becomes this. Now we will move for question number 8. This is important also. I found it is given in some exam. So as it came in exam, so you should be careful and try to do it, practice it. Now question number 8, find the values of x for which y is equal to x into x minus 2 whole thing square is an increasing function. So question number 8, y is what? X inside bracket x minus 2 and it is whole thing square. This is our y, and we have to prove that it is increasing function for what interval, that we have to find. Interval we have to find. Now dy dx, if we want to break this one, it will be better x square, and if we break this one, then it will be what? X square minus 4x plus 4, and again if we break x to the power 4 minus 4x cube plus 4x square. This is now if we break this one. So dy dx, it will be what? If we differentiate, it is 4x cube. This one will be 12x square. Actually 4 and x cube's differentiation is 3x square, so 12x square. 4 differentiation of x square is twice x, so it is 8x. If we take 4x common, it is x square minus 3x plus 2. If we factorize this one, so if you multiply these two, you will get, so I know the value of factorization so many times I have done, so we can write this one as like that. If dy dx is 0, then of course this term 0, and we get x as 0, this will give 1, this will get 2. So we get how many intervals? 0, 1, 2. So minus infinity to 0, then 0 to 1, then 1 to 2, then 2 to infinity. So we get 1, 2, 3, 4, 4 interval. And we have to find that at which interval it is strictly increasing. It is increasing function. So we have to search for minus infinity to 0. This one. So minus 1 you can take. If you put here minus 1, this will be negative, this will be negative, this also will be negative. So what we get? Dy dx, this is less than 0. Now if we take 0 to 1, now any value in between this, if we take dy dx, this will be what? For 0 to 1, suppose half you have taken. This is positive, half minus 1 negative, half minus 2, it is also negative. This term will be negative. If we take half in between 0 to 1, half you put here, this will be positive, half minus 1 negative, half minus 2, that is also negative. Negative, negative multiplication positive, so it is greater than 0. So for 0 to 1, we get this one as positive. For 1 to 2, if we consider, any value in between 1 to 2, suppose 1.5. Here if we put, it is the 4 into 1.5 positive number. 1.5 minus 1.5, that is the positive. But this one, 1.5 minus 2, it is 0.5 minus 0.5, it is negative. So this is less than 0. Now last one, that is for 2 to infinity. If we consider this one, suppose any value greater than 2, it is suppose 3. 3 if you put, this one is positive, 3 minus 1, 2, it is positive, 3 minus 2, 1, it is also positive. So we are getting what? dy dx is positive. They say increasing. So you find 0 to 1 and 2 to infinity. So if we consider this for these two interval, so we write for this y is increasing. Why y increasing? Because dy dx we found at that interval is positive. So we have to write that at that interval our y is strictly increasing. Yes, it is open interval, so of course you can say. So with that we end our today's class. Up to 8 we have finished. Okay, thank you for watching.